This worksheet is to show you how to name ketones. Naming ketones is really similar to naming aldehydes. So the first thing that we have here in this is a list of the steps that we're going to follow. The carbonyl group in a ketone is a very high priority functional group. The only thing higher would be an aldehyde. So we want to start by finding the longest carbon chain that contains the ketone functional group and then numbering that carbon chain to give the ketone the lowest possible number. The ketone, unlike the aldehyde, the ketone functional group could be anywhere on the carbon chain. So its location is not implied. It's not going to be carbon number 1 ever. That would make it an aldehyde. And we do always have to think about stereochemistry. For this particular example, we don't have any stereochemistry, so we skip that step and go straight to the substituent, a methyl on carbon number 3. To name the aldehyde, we're going to base the name, to name the ketone, we're going to base it off of the number of carbon atoms in the parent chain. This is a 4-carbon chain, so it's based off of butane. To express this as a ketone, we're going to drop the E and replace it with -one. So this is going to become butanone. Again, we're only dropping the E, butanone. We have to say the location of the carbonyl group for the ketone, and we can put that location in front of butanone. So we could call this guy 3-methyl-2-butanone, or we can put the location in the middle of the name, so we could call it 3-methyl-butan-2-one, whichever you would prefer. Let's try the practice over here. So first we have to find the longest carbon chain that contains the ketone group. The longest carbon chain containing the ketone group is that one right there. And now what we want to do is number the carbon chain. And our goal is only to give the carbonyl group the smallest possible number. Even though we do have another functional group, we have the carbon-oxygen double bond on here, we don't care at all about how we're going to number that carbon-carbon double bond. We only care about giving the carbonyl group the smallest possible number. So there's our numbering. This is an alkene, but we don't have any stereochemistry because it's a terminal alkene. The double bond's at the end of the chain. So we can go straight to the substituents. We have a substituent on carbon number 4, and that substituent is a methyl group. So that's going to be the beginning of the name. And then to name the parent of this molecule, a 5-carbon molecule is normally called a pentane. This has a carbon-carbon double bond, so that means it's going to become a pentene. We do need to say where the double bond is located. So this is specifically a pent-4-ene. And because it's a ketone, we have to say, drop the E. This is a pent-4-ene-one. But remember, with ketones, the carbonyl group could be pretty much anywhere. We have to say where the carbonyl group is located also. So this is a pent-4-ene-2-one. People, this is why IUPAC came up with the rule of putting the numbers in the middle of the name. Because if we weren't putting the 4 and the 2 in the middle of the names, things would get very confusing. So this molecule's full name is 4-methyl pent 4-ene 2-one. Fix that. Let's practice. So our first one to practice, we've got our longest carbon chain. We want to number it so that the carbonyl group has the smallest possible number. We do have some stereochemistry with this alkene. How did I manage to count that wrong? We do have stereochemistry, carbon 3 and 4. That is a trans or an E isomer. I'm going to call it an E. Now we're going to name our substituent. On carbon number 5, we have chloro. Now we want to come up with the parent name for this molecule. 6 carbons makes it a hexane. We'll go ahead and start with the hex. It has a double bond, so it's not a hexane, it's a hexene, and the ene is located on carbon number 3. It's not just a hexene because it's also a ketone. The ketone is located on carbon number 2. 5-chloro, hex, 3-ene, 2-one. And let's look at the next one. Here's a cyclic one. So our longest carbon chain that contains the ketone functional group is the ring, and we want to give the ketone the smallest possible number, so we get to actually give it number 1 this time, and then we number around the ring to give bromine the smallest possible number. We are going to start by naming our substituent. On carbon number 3, we have our bromo. This is a cyclohexane. With a ketone, so we're going to call it cyclohexane, drop the E, one. And like with cyclics, like in the case with cyclics, when your high priority functional group is on carbon number 1, you don't need to say that it's on carbon number 1. It's understood that it's on carbon number 1. So we don't have to say 3-bromo, cyclohexane, 1-one. We all know that the one is on carbon number 1. Here's another one. This one has 2 carbonyl groups. So this is a diketone with 2 carbonyl groups. So that means we want to find the longest carbon chain that contains both of the carbonyl groups, and we want to number it so that together they have the smallest possible set of numbers. And that's going to be numbering it from left to right so that they're on carbons 2 and 4. We're going to name our substituent. On carbon number 5, we have a methyl. And then we're going to go with our parent name. It's a 6-carbon chain, so it's a hexane. But it's not just a hexane, it's a hexanone because it has ketone on it. It has 2 ketones on it. We do need to say that they're both there, and the location of both of them needs to be provided. They're on carbons 2 and 4, hexane. And just to be really clear, we're not going to call it hexanone. We're going to call it a hexane dione. Hexane dione. So the di means that we have 2 carbon-oxygen double bonds. Whenever we have a di functional group, like a dione or a diol or a diene, we always keep the E. Keep the E with a dione, or with a diol, or with a diene. Last but not least, we have 3 ketones that are very frequently used in the lab, and they go by common names, but you need to know their common names. The first one is our friend acetone. Its IUPAC name is 2-propanone, but we all call it acetone. The next one you should remember from last quarter, this is acetophenone. This was one of the benzene derivatives that I asked you to memorize. And the last one, some of you might be familiar with this because we use this a lot as an unknown. This is benzophenone, and it was one of the unknowns that we used in 251.